Hi guys, so this is a new video on stationary and inflection points. In this video we shall focus on problems that require us to analyze equations. In this video I shall tackle the three problems on the screen in front of you, and I shall begin question 1 shortly. So question 1 came in paper 1, May 2009, time zone 2, question number 6. Kindly take a minute to look through the question and my explanation shall follow shortly. Now would be a good time to pause the video. So in question A we are required to find the second derivative given that this is the first derivative. So basically we need to differentiate this function, and this is a simple chain rule problem. It's not even a chain rule problem, it's a very direct question. We multiply by the old power and we reduce the power by 1, and whatever is inside the bracket differentiates to 1. So x minus 3 differentiates to 1, so there is no derivative to multiply by the answer. As for question B, you are required to find f dash of 3 and f double dash of 3, which is simply found by substituting x for 3 in the given equations. So f dash of 3 requires that we put 3 instead of this x, and hence we get 0. Similarly, f double dash of 3 requires that we put a 3 instead of this x, and we also get a 0. So for question C, we are required to explain why P is not a point of inflection where P has x coordinate 3. We know that if f dash is 0, then we have a turning point. If f double dash is 0, then we probably have an inflection point. But we are only certain that we have an inflection point if f double dash is negative before and positive after, or positive before and negative after. So in other words, f double dash has to equal 0 and has to change sign before and after 3. So this is not the case here. If we substitute x equals 2 in the blue equation to get f double dash of 2, we get 2 minus 3, which is negative 1, squared, which is 1, times 3, which gives me 3. And if we substitute 4 in the same equation, we get 4 minus 3, which is 1, squared, which is 1, multiplied by 3, which is 3. So in both cases I have a positive answer. It doesn't matter whether the numbers are the same or not. Here by coincidence they are both 3, but what concerns me is that they're both positive. So since f double dash does not change sign before and after x equals 3, hence f double dash of 3 is not an inflection point. So this is the end of the first question. Pause the video if you would like to copy this down. I shall begin the second question shortly. So the second question came in paper 2, November 2010, question number 7. Kindly take a minute to look through the question, pause the video, attempt to solve, and my explanation shall follow shortly. So in question A, we are told that there are 2 points of inflection on the graph of f. Write down the x coordinates of these points. Now we know that the definition of a point of inflection is that f double dash is 0 and changes sign before and after. Here we are already told that there are points of inflection, so we don't have to do the test of changing the sign before and after. We simply have to get the x coordinates where f double dash is 0. And since we are already told that there are 2 points of inflection, so if I have 2 answers, then I know for sure that they are both actual points of inflection. So what we're going to do is we're going to get f double dash and equate to 0. So f double dash involves a simple differentiation process, and you get the blue equation right there. And now we want to equate this equation to 0. Of course, there are manual ways to do that, but since this is paper 2, I shall not waste time with the quadratic formula. I shall simply use the GDC to get the x-intercepts of the curve. So I sketched the curve f double dash of x right there. I'm going to click on trace. I get this quadratic function. In order to get where f double dash is 0, I'm going to press on second, trace to get the calc operation, and I'm going to select 0. I'm required to get the left bound of the 0. So the 0 is where I cut the x-axis, so I'm going to drag the cursor to the left of that point. Next, I'm required to get the right bound of the x-intercept, so I'm going to drag the cursor again to the right of that point, somewhere here. Finally, I need to guess where the x-intercept is, so I'm going to try to get my cursor as close as possible to the x-intercept, somewhere here. And the calculator tells me that the x-intercept is at 0.3643, or simply 0.36. So one of my solutions is 0.36. I then repeat the process for the second x-intercept. Again, second, trace, and then get the 0 calculation. Identify the left bound, so somewhere to the left of my x-intercept. Now identify the right bound. Finally, guess where the x-intercept is. And the solution is negative 0.114. So we are done. We got the 2 x-intercepts. We no longer need the GDC now. I simply write the 2 solutions down, negative 0.114 and 0.364. For question B, we are told let g of x equals f double dash. Explain why the graph of g has no points of inflection. So if I am going to analyze inflection points for g, I need to get g double dash. So g is the same as f double dash. The green equation is just the same as the blue equation. And I differentiate it twice to get g double dash. This is simple differentiation. Now, why does this graph right there have no point of inflection? Simply because g double dash is always negative. Since g double dash is always negative, then there is no change of sign. It will never be 0 and it will never change its sign. So since g double dash shall never change sign, g shall never change concavity. Hence, g shall never have an inflection point. So this concludes question number 2. Take a minute to write this down if you will, and I shall begin question number 3 shortly. So question number 3 came in paper 1, May 2010, time zone 1, question 9. Take a minute, pause the video, attempt to solve, and my explanation shall follow shortly. So question A requires us to use the quotient rule to find f dash and show that it is the same as what they have written. This is a simple quotient rule problem. I have cosine x over sine x. I use vu dash minus uv dash over v squared. And for reference, you can access older videos that tackle product and quotient rules. In these videos, questions of the sort are solved in more detail. I do some algebra to simplify the numerator here, and I use the trigonometric identity sine squared x plus cosine squared x equals 1 to arrive at my final answer. In question B, I'm required to find f double dash of x. I begin by rewriting f dash in a slightly different way. So negative 1 over sine squared x is the same as negative sine x all to the power of negative 2. This format shall help me use the chain rule more efficiently. I multiply by the old power, I reduce the power by 1, and I multiply by the derivative of what's inside the bracket, hence obtaining a function that looks like this. So the first part of the question is simple and depends on previous knowledge. Let's move on. So in question C, we are required to find the value of P and of Q, where P is f dash of pi over 2 and Q is f double dash of pi over 2. This simply entails removing x and plugging pi over 2 in the functions I've already obtained, which are f dash and f double dash. So P is f dash of pi over 2, so I remove x in f dash and put pi over 2. Sine pi over 2 is 1, sine 90 is 1, so negative 1 over 1 squared is negative 1. And f double dash of pi over 2 requires the same process. I plug pi over 2 for x in the equation of f double dash, getting negative 2 cosine pi over 2 divided by sine pi over 2 all cubed. Now cosine pi over 2 is 0, sine pi over 2 is 1, so you get 0 over 1, which is 0. So if f double dash is 0, I suspect that there might be an inflection point. But in order to confirm, I need to see whether f double dash changes sign before and after pi over 2 or not. And this is apparent in the table. F double dash of pi over 2 is 0. We already got that. Before pi over 2, so pi over 2 minus 0.1, I had a positive value for f double dash. After pi over 2, I had a negative value. Hence, f double dash is 0 and it changes sign before and after. Hence, there is a point of inflection where x is pi over 2. So this concludes the third question in this video, and it concludes the entire video. I hope you have found it useful. Pause the video to copy this down if you will. Thank you.